Alright, we did an example like this on the homework. This is number 17 on 6.5. We're eliminating the parameter. So I showed you last time that we can kind of use Pythagorean theorem or Pythagorean identity, right? So if we solve this so that sine 3t equals x divided by negative 4, and cosine 3t equals y divided by 4, and then we plug those into our Pythagorean identity. And that should equal 1, right? Well, let's just say that theta equals 3t. Okay, so that just means whatever the time is, it's multiplied by 3. But the fact is, we're getting rid of the parameter. So do we even care that the parameter is multiplied by 3? No, it really doesn't matter because all we're doing is getting rid of the parameter. We just want to know what x and y are doing. So for x and y, we can plug this in for sine, so x over negative 4 squared, and for cosine y over 4 squared. And of course, when you square a 4 or a negative 4, it doesn't matter. It ends up being 16, right? Oh, that should be x. So then that can be rewritten as x squared plus y squared equals 16. And what shape is that? That is a circle with radius 4. And it didn't put any kind of restriction on t. So since it didn't restrict t, there's no starting and stopping place. It's just going forever. So it doesn't matter that the t value is tripled because it will still just go forever in that same circle. Just the tripling t means it's going to the object that's traveling would be traveling at a different rate than if it was just t instead of 3t. Does that make sense? It doesn't affect the actual shape of the parametric graph that the object is traveling. It just changes how fast it's traveling, and that's not part of this question. So that's all we care about right there. Any other questions on 6.5? Alright, 24 is a line segment. Start at negative 2, 4, at t equals 3, and end at the point 5, negative 9, at t equals 7. Alright, so basically we're doing two equations. X equals mt plus b, and y equals mt plus b, and they are just two completely separate equations following the slope-intercept form. Instead of plugging in x, we're plugging in t, and in this one, we plug in t, we get out x, we plug in t, we get out y. Okay? So two separate equations for the horizontal position and the vertical position of the object. Alright, so let's start with the x graph. All we care about is x and t. So I'm going to organize this a little differently than I did the example on the assignment last time, just to help it make more sense. So what I'm going to do is take the t and then the x value and put it as points. So when t equals 3, what is x? And when t equals 7, what is x? 5, right? So then to find m, that's the slope. In this case, x is our rise and t is the run, right? For this particular thing. We're not actually graphing it that way, but as we're creating this y equals mx plus b equation, we have to think about it that way, as x being the y value and t being the x value. So for our slope, we do the rise numbers, y minus y over x minus x, more or less, only it's x and t instead. So that gives us 7 over 4, 7/4. Does that sound right? Okay, so then we would have x equals 7/4 t plus a starting point b. Now when we did this problem in class, like an example like this, t was 0. And so that meant that the starting point was just these numbers, because it was t equals 0. What's the problem with this one? t is not 0. So now we have to find the y-intercept without having that easy point there. We do know, though, that t at 3, t equals 3, x is negative 2, and at t equals 7, x equals 5. Can't we just plug in one of those x and t values and solve for b? Plug in I guess it's tx, sorry. Alright, so which one do you want to plug in? 7 and 5? Okay, so we'll plug 7 in for t and 5 in for x. So 5 equals 7/4 times 7, and I'm going to put it over 1 so it's easier to multiply. So 7 times 7 is 49 divided by 4. This is getting a little ugly. So we have 49/4 plus b. So to find b, we're going to have to go 5 minus 49/4. Okay, well let's change 5 to fourths instead. 20/4, correct? Does that make sense? Minus 49/4. So the 5 turned into a 20 over 4, and then we're subtracting it to the other side, the 49/4, so we can find b. So that tells us that b should be negative 29/4, I think. Now we can finish that equation. So that equation is x equals 7/4 t minus 29/4. There's the horizontal path. Alright, now we do the same thing for the vertical path. So this time we're going to put our numbers into t and y. So t is 3, y is 4, t is 7, y is negative 9. We find our slope by going 4 minus a negative 9 over 3 minus 7. I did it backwards that time, but oh well, it doesn't matter. So 4 minus a negative 9 is positive 13, and 3 minus 7 is a negative 4. So the slope is negative 13 over 4, right? So then we have y equals negative 13/4 t plus b. We need to solve for b. So let's plug in one of the points. Do you want to plug in 3 or 4? 3, 4, or 7, negative 9. Okay, plug in 3, 4. So 4 here, 3 here. So that means 4 equals negative 39/4. So let's change the 4 to 16/4. And then we would need to move negative 39/4 over with that. So it's going to be a positive 39/4, which gives us 55/4. Does that sound right? So then that equation is y equals negative 13/4 t plus 55/4. And there is the vertical equation. Did anyone check that answer in the back? No, because it's even. So I just want to check our answers really fast. Question 24. It says, according to the answer solution manual, x equals 7t over 4 minus 29/4, and y equals negative 13 over 4t plus 55/4. Did we get them? Yes. Now, of course, you should also specify where the t value is for those, where t is from 3 to 7. That's actually kind of part of your answer to define the parameter. They gave it to you, but it's kind of stating the obvious, but you're supposed to list the parameter. The book actually did it like this. 3 is less than or equal to t is less than or equal to 7. That's another way of writing it, right? Doesn't that mean the same thing, sort of? I think my notation is maybe a little weird there, but you still know what it means, so it's good. I think we're good either way. Alright, question 24. Anything else? No? We're good? Okay. So stop my movie.